All right, in this Algebra 2 tutorial for the Big Ideas section 1.2, transformations of linear and absolute value functions. So we're going to talk about translations, reflections, stretches and strengths, and also being able to use a combination of those transformations, but looking at just linear and absolute value functions. So two different directions of translations we can make. You can either translate or shift a graph horizontally or vertically. If you shift a graph horizontally, then that number that you are shifting is either going to be added or subtracted inside of your equation. So notice how there are parentheses around this f of x for your parent function, and it's inside this parentheses whenever you have a horizontal translation. Horizontal translations work kind of in the opposite direction, where you're going to see the opposite number that's being shifted. With translations, it's a little bit more forgiving on the number because both vertical and horizontal translations are the same because you're not changing the slope of the graph. But just kind of start to get used to the idea of horizontal translations. Your number is changing inside the parentheses, while vertical translations, a number is being outside of the parentheses. And the letters that you're going to be familiar with for the rest of this unit and other transformations are H and K. So H is the number for horizontal that is on the inside of the parentheses, and K is the variable we're going to use for the vertical translation or outside the parentheses. All right, so looking at a parent function of a linear and getting f of x is 2x plus 1, we're going to write a function g whose graph is a translation of 3 units down from that f of x, and then write a function h where it is translating 2 units to the left of that graph of h. So this is going to be our starting equation, 2x plus 1. Not necessarily a parent, but this is what we're starting with. And then for g, we're going to translate it 3 units down. So whenever you're going down, that is a vertical translation. And that just means you're taking -3 for down and adding that to each of your output values. Remember last time we had tables. So you're just taking that -3 to all of your outputs. You could also take it to just your equation of f of x and just add -3 to your outputs. So you have your f of x, which is 2x plus 1, adding a -3 to it, and that just becomes 2x minus 2, and that's your new g of x function. Moving on to part B, taking your original f of x of 2x plus 1, a new equation h that is being translated 2 to the left. That means you are subtracting 2 from each of the input values. Because of the horizontal translation, that's why it's inside the parentheses. So when you write your f of x, you are subtracting that -2 from the input, which becomes the opposite because it's inside 2x plus 2, x plus 1. You combine the 2 and the 1, distributing the 2 to get 2x plus 4, and then add the 4 plus 1 to get 5. So that is taking your 2x plus 1, shifting 2 units to the left. And that's kind of what it looks like on the graph if you choose to use it on the graphing calculator. All right, reflections. So you can have 2 different types of reflections that you're going to be familiar with. One is going to be a reflection over the x-axis, or you may think of it as a vertical flip, so it's going up and down. And then there's your reflection over the y-axis, which is this way. Your reflection over the x-axis can be thought of as vertical because it is happening outside your equation. So that negative is being multiplied out in front of your f of x. And it multiplies all of your outputs by -1 and changing the sign because it's the vertical. But the horizontal one is happening on the inside because it's over the y-axis, and that means you're multiplying all of your inputs by -1 to change their signs. So looking at an example with an absolute value this time, we're going to write a function g that is a reflection over the x-axis of our f, and then the h is going to be a reflection over the y-axis. So we're always going to go back and start to this f of x, which is absolute value of x plus 3 plus 1. So your reflection of the x-axis changes the sign of each output value. So you're going to be multiplying on the outside of your parentheses or of your function of your equation. So you have your negative times the entire thing on the outside of your absolute value, x plus 3 plus 1. And then you're just going to use the distributive property. So you multiply your negative times the whole thing of the absolute value, and then the negative times the positive 1 to get -1, and that is your g of x. Moving on to the reflection of the y-axis, that means you are changing and multiplying by the -1 for all of your input values. So that means you are multiplying on the inside of all of your parentheses. So that's why you are multiplying by only the -1 inside your equation. You factor out that -1 from the x to make sure that you have negative times the whole thing. Using your product property of absolute values, because +1 and -1 lead you to the exact same thing of absolute values. So it becomes absolute value of x minus 3 plus 1. And you can kind of check on the graph just to see what that looks like. So your f black is your original x plus 3 plus 1. Your g is the one that is being reflected over the x-axis, so it is now pointing down and below the x-axis. And then your reflection to f is the reflection over the y-axis. All right, stretching and shrinking. So we can have both horizontal and vertical, and it's again going on to the same theme of inputs and outputs. So your horizontal stretching and shrinking is all of your inputs because it is inside the equation. And that is where your a is greater than 1, it is a stretch. But if it is less than 1, it is going to be a shrink. Same thing with vertical. Vertical is happening outside the equation because it is affecting your outputs. And again, if a is less than 1, it is a shrink. If a is greater than 1, it is a stretch. So looking again at an absolute value, you have x minus 3 minus 5, and we're writing a function that is a horizontal shrink by a factor of 1/3. And then for part B, writing a graph that is a vertical stretch by a factor of 2. So a horizontal shrink means that you are multiplying by the 1/3 to each of your input values because horizontal affects all of your inputs. So inside your equation, you're going to multiply by a value of 3, which is the reciprocal of 1/3. Multiply that 3 times just the x inside your equation, and that is the new transformed function. The vertical stretch by a factor of 2 multiplies all of your output factors by a value of 2, so that is happening outside the equation. So 2 is going to be multiplied times the whole thing outside of the parentheses, absolute value of x minus 3 minus 5, using your distributive property to multiply the 2 times just the absolute value portion, and then 2 times the -5 to get -10, and that would be your new function. And here's what they would kind of look like. So your black f function is the x minus 3 minus 5. Your g is that horizontal shrink, and your h is the vertical stretch. All right, so let's the graph of g be a vertical shrink by a factor of 0.25, followed by a translation of 3 units up. So this is using a combination of transformations all at once. And then we're going to write the rule for our g. So we're starting with the graph of just a basic linear function, y equals x, or f of x equals x. So we're going to write the function h that represents first the vertical shrink of f. So vertical means you are affecting the outputs, and it is a vertical shrink by a factor of 0.25. So we're just going to multiply by 0.25 on the outside for the vertical shrink. Then you're going to write the function g that represents the translation of h. Your translation is just 3 units up, and since it is vertical, that means you are affecting the outputs of the equation. So you're just going to add at the end plus 3, and there's your new function, 0.25x plus 3. That's what it looks like on the graph. If you're checking on the graphing calculator, your black f is just f of x equals x. And then your g is what it looks like when you vertically shrink by a factor of 0.25 and then translate 3 units up. So moving on to an application, let's say you're designing a computer game. Your revenue for x downloads is given by a function of f of x equals 2x. Your profit is $50 less than 90% of your revenue for x downloads. Describe how you would transform the graph of f to model the profit, and then estimate what the model is for 100 downloads. So let's understand this piece by piece. You're given a function that represents your revenue and a verbal statement that represents your profit. You're asked to find the profit for 100 downloads. Revenue does not necessarily mean profit. You need to write a function that represents your profit and then use this function to find the profit for 100 downloads. So your profit is a function of 90% of your revenue minus $50. 90% written as a decimal, you just move it over twice, 0.9, times your revenue function, which is our f of x equals 2x minus 50. That 0.9, because it's less than 1, is another way to say vertical shrink. And then your minus 50, because it's happening outside and dealing with your outputs, is a translation of 50 units down. So we're just going to substitute in the 2x for the f of x, because that's what we are given for our revenue function. Simplifying that down, because of the 0.9 times 2, you end up getting 1.8x minus 50. So to find the profit for 100 downloads, you just substitute in 100 into your x. 1.8 times 100 minus 50 equals 130. So your profit for 100 downloads is $130. So looking back on it on the graph, there is your f function just by itself. And then when you transform it using the 1.8x and minus 50, the vertical shrink actually decreases the slope, and then the translation brings it 50 units down. So the graph of P, which is your profit, is not quite as steep as the graph of your F for your revenue, because revenue is just the amount of money you make. Profit is how much you make after how much you are spending on something. So there are a little bit of adjustments to be made.